Welcome to The Explainer. So, today we're going to dig into something really cool, a brand new system that smashes one of the biggest bottlenecks in AI. We're talking about a way to train some of the most advanced AI models way faster, like up to 3 times faster.
Okay, so here's what we've got on tap. First, we'll talk about a huge problem holding AI training back. Then, we'll get into the big idea that flips the script. We'll see how this system, it's called AREAL, actually works, how it deals with a tricky side effect, and then, you guessed it, we'll check out the amazing results.
All right, let's jump right in. The first thing we got to understand is this massive hurdle that's holding back AI development right now.
So, we've got these incredibly powerful AI models, right? But here's the thing. Teaching them to get really good at complex stuff, think math problems or writing code, is just painfully slow and super expensive. So what's the deal? Why does it take so long?
Well, it really boils down to this two-step dance. First, the AI has to generate a ton of data. They call these rollouts. Then, and only then, it starts training on all that data it just made. The keyword there is traditionally. One phase has to totally finish before the next one can even think about starting.
And this is where the problem really hits. In this old-school synchronous way of doing things, you've got a bunch of GPUs working on generating data. But here's the catch. Not all those generation tasks take the same amount of time. So you end up with some of these super expensive, super powerful GPUs just sitting there, twiddling their thumbs, waiting for the slowest one to finish. It's a massive, massive waste of time and computational power. That's the bottleneck.
Okay, so how do we fix this? How do we break that bottleneck? Well, the core idea behind the solution is actually really elegant and surprisingly simple. Let's use an analogy. Think about a restaurant kitchen. The old way, the synchronous way, is kind of like having just one chef. That chef has a big, slow roasting dish in the oven, and they literally can't start the next order until that first one is completely done. Meanwhile, parts of the kitchen are just sitting empty. But the new idea, the asynchronous way, that's like a modern assembly line. You've got one team just prepping ingredients, that's our data generation, while another team is over at the stove actually cooking, that's training the model. Everybody's busy all the time, no waiting around. So the whole idea really comes down to this. What if we just stopped waiting? What if we completely decouple the two jobs? Let the data generators just generate and let the trainers just train, all at the same time, in parallel. No more waiting for each other. And that's exactly what this new system does. It's called AREL, and it's built from the ground up to make this whole asynchronous idea a reality.
So this diagram gives us a great look at the architecture. On one side, you've got this team of what they call rollout workers. Their only job is to just crank out new data, constantly. Then, on the other side, you have trainer workers. They just reach into a shared pool of data, grab a fresh batch, and use it to update the model. The key is they're running in parallel. The trainers don't have to wait for the generators to finish a whole batch, and the generators don't have to wait for the trainers. It's a continuous flow.
Okay, let's quickly break down the key players here. You've got the interruptible rollout workers. They're the ones making the data. They can be paused for a second to get the latest version of the model, which is pretty neat. Then you've got the trainer workers who are doing the learning. And in the middle of it all is the replay buffer. You can think of it like a waiting room where all the freshly generated data hangs out before it gets used for training. And overseeing this whole operation, that's the rollout controller, basically the brain that manages the whole symphony.
Okay, so this all sounds great, right? Super fast, super efficient. But there's a catch. This high-speed approach creates a brand new, kind of tricky problem. And solving it required a really clever fix, not just in the system, but in the algorithm itself.
And that problem is something called data staleness. Think about it. Because the data generators and the trainers are working at their own pace, a trainer might grab a piece of data that was created by a much older version of the AI model. It's like trying to learn for a history exam using a textbook from 1950. The information isn't wrong exactly, but it's outdated and it can really confuse the AI and mess up its performance.
So AREAL tackles this with a really smart two-part solution. First, they put a hard limit on how old the data can be. It's a simple rule. If the data is too stale, you just don't use it. This keeps a nice balance between speed and freshness. The second part is a bit more technical, but it's super cool. They tweaked a popular training algorithm called PPO. Now, PPO is basically a way to make sure the AI learns in small, safe steps instead of making wild, crazy updates. AREAL's special version of PPO is designed specifically to handle slightly stale data without getting thrown off course.
And this, right here, is what makes this so brilliant. It's not just about building faster pipes. It's about co-designing the algorithm and the system so they work perfectly together.
The authors themselves say that this algorithmic tweak is what keeps the model's updates grounded and stable, even with that slightly stale data. It's a beautiful example of algorithm system co-design.
Okay, so we've talked about the clever system, the smart algorithm, but does it actually work? What's the payoff? Let's get to the results, because they are seriously impressive. Check this out. AREAL is up to 2.77 times faster. That's nearly a 3x speedup compared to the old synchronous systems using the exact same hardware. And here's the kicker. This isn't one of those things where you trade quality for speed. No way. The models trained with AREAL performed just as well, and in some cases even a little bit better, on really tough math and coding tests. So you get all that speed with zero downside to performance.
This chart really tells the story. Look at the blue line. That's AREAL. As you throw more GPUs at the problem, the performance just keeps going up and up in a nice, almost straight line. Now look at the orange line. That's the old synchronous system. It gets a little faster at first, but then it just plateaus. It hits a wall. This shows that AREAL is built to scale, which is absolutely crucial for the massive AI training jobs we're doing these days.
And this table just drives the point home. Look at these numbers. For a 1.5 billion parameter model doing math, they cut the training time from 41 hours down to just under 15. For a 7 billion model, it's from almost 58 hours down to 25. That's more than cutting it in half. Across the board, for different model sizes and different tasks, AREAL just crushes the training time.
So when you step back and look at it, the big takeaway here is that by rethinking this fundamental workflow, by decoupling generation and training, systems like AREAL are not just an incremental improvement. This isn't just a small speed bump. This fundamentally changes the economics and the timelines for developing the next wave of advanced AI. And that leaves us with a really exciting final thought. If we can now train these incredibly powerful models 2, maybe 3 times faster, what new frontiers of machine intelligence are we about to unlock next?